Getting your review for the rational expressions and proportions test you have here. So let's get right into it. The first part is going to ask for excluded values for the rational expressions. And all that means when you have excluded values, that just means you set your denominator equal to 0. So all I'm going to do for all these is just set my denominator equal to 0. So 60x squared equals 0, divide both sides by 60, and I get x squared equals 0. That means my excluded value is just x equals 0. For number 2, same thing. X plus 1 equals 0, so subtract 1 from both sides. I should get x equals negative 1. That is my excluded value. That's my domain error. For number 3, to set this whole thing equal to 0, that means I'm going to have to set the bottom equal to 0 by factoring. So factors of 18 that subtract to 3 should be 6 and 3 with an x in each. Bigger sign, or a bigger number gets the sign in front, and then the only way to make it positive 3 is if it's negative 3 equals 0. So when I have this, I need to set each one of these equal to 0. So I'll have x plus 6 equal to 0, and x minus 3 equal to 0. So my excluded values are x equals negative 6, and x equals positive 3. Those are my two excluded values. And number 4, they're already in that factored form. So I don't need to worry about anything. I can just set each one equal to 0 immediately. X minus 1 equals 0, and x plus 3 equals 0. So my excluded values are x equals 1 and x equals negative 3. Something to keep an eye on. Even though these cross out and factor out, you still need to include them in your excluded values. Number 5, setting him here equal to 0. When I set this here equal to 0, 4x minus 30 equals 0. Add 30 to both sides to get 4x equals 30. And then divide by 4. So x equals 30 over 4, which simplifies into 15 over 2. The excluded value is 15 halves. And number 6, I can factor this bottom to be x times x minus 4. That's what I set equal to 0. So that means each of those factors, including the x, equals 0. So x minus 4 equals 0 and x equals 0. So my two excluded values are x equals 0 and x equals 4. All right, in these ones, just simplifying the rational expression, we need to have them in forms that look like this. Everything factored on the top and the bottom, and if anything cancels out, then we have exactly what we need. So in this case, an x plus 9 factor on the top and bottom both cancel. So my answer here is 1 over x plus 8. Same here, except my bottom is not factored. So let's rewrite it. I can rewrite the bottom factors of 8 that add to 6. Those are, well, not 8. They should be, undo that. It should be, factors are 4 and 2 with an x in each, and they both need to be plus. So again, here as you can see, we have x plus 4s on the top and bottom that cancel. So that means that my factored or simplified expression should be 1 over x plus 2. And number 9, we need to factor this because we can't cancel any terms that are added. We can't go and do that because those are added terms. They can only be factored. So don't try to just cancel out those x squareds. I can pull out an x from this to begin with and leave x squared minus 2x minus 15 up top. Then I can factor that even more. Factors of 15 that subtract to give you 2. Those are going to be 3 and 5. So I have a 5 in one, a 3 in the other, obviously an x in each. And then this minus in front means the bigger number gets a minus, and the only way to make it a negative 2 is if this guy's a plus. Now remember, I also pulled out an x, so I better keep that x out in front of it. On the bottom, factors of 5 that add to 6 are 5 and 1. So a 1 and a 5 with an x in each. Those factors, need to both be negative. It's the only way I can get it to add up to negative 6. And again, what cancels out? In this case, my factors that cancel out are the x minus 5s. And that leaves me with x times x plus 3 on the top and an x minus 1 on the bottom. Oops, wrong button. So, okay, number 10. Now we have a little bit more things happening. We have some multiplication. Notice, though, everything's already factored. These guys are able to be factored, or they already are factored, I should say. But I can look and see, well, these are the exact same factors there. And I have a 4 on the top and bottom that can cancel out. So the only thing I have left is just that x minus 6 up top. I could say that's over 1, but that's unnecessary because anything divided by 1 is just itself. Okay, some more interesting ones here. I need to factor here again. Factors of 4 that add to 5 are going to be 4 and 1. So I have a 4 and a 1 with an x in each. The only way that I can get it to be positive 5 is if both are positive. And this guy here will be x minus 4 times x plus 4 because that's our difference of squares. I can take the square root of each, make one a positive, make one a negative. So what can cancel out? We have on the top an x minus 4 and an x minus 4 on the bottom to cancel. Over here I have an x plus 4 up top and an x plus 4 on the bottom that will cancel. So the only thing that I have left is an x plus 1 up top and an x minus 5 on the bottom. So there is your reduced, simplified expression. In number 2, we have a lot, or number 12, I mean, we have a lot of factoring here. First, this guy, I can pull out a 10, and I can pull out an x. When I do that, I'd be left with x minus 2. Do your FOILing back in to confirm that. 10x squared and negative 20x. Perfect. On the bottom, I can pull out a 40 and an x squared. That'll leave me with an x minus 2. On this guy, I can pull out a 16. I can also pull out an x squared. That'll leave me with x plus 5. And on the bottom here, I can pull out a 6, and that'll leave me with an x plus 5. So what can cancel out? My x plus 5s here go away. My x minus 2s go away. I have a pair of x squareds, one from the top, one from the bottom. Then the other things I can do is, well, I can say, well, I can divide both 10 and 4 by a number. I can divide them both by 10. So that would leave me with a 1. This would leave me with a 4. I can also say, well, then I have a 16 and a 4. I can divide each of those by something. So I'll divide each of those, get another color here, each of those by 4. That'll leave me 4 here and 1 there. So now I just have 4 and 6. Well, I can reduce that even more. I can divide each of those by 2 to get 2 and 3. So the only things I have left, I have a 2 and an x up top, and I have a 3 on the bottom. You could have multiplied everything out and then canceled. I try to cancel early as best as possible. All right, here in number 13, when I have division here, that means that I need to flip and multiply. So what I'm going to do is I'm going to rewrite the first guy, x plus 8 over. I have x plus 8 and x minus 10 on the bottom. That stayed the same. I need to flip it to multiply. So what was on the bottom now goes up top. What was on the bottom now goes up top, and then what was on the bottom, or what was on top, now goes to the bottom. Now I have a multiplication problem. Now I can try to cancel things out. So I have an x minus 10 on the top and the bottom, and I have an x minus 7 on the top and the bottom, and even one more here, I have this x plus 8 on top and bottom. So the only thing I'm left with is the x minus 2 up top and the x plus 2 on the bottom. And no, those do not cancel. You cannot cancel because these are not the exact same thing. All right, same here. I'm going to both factor and flip it around. So I'll have x plus 5 up top. It's already factored. On the bottom, I can pull out an x and be left with x plus 5 on the bottom. Flip and multiply, so it's not going to be multiplication. This bottom will go to the top. I can pull out a 5 and an x from that and be left with an x plus 1. And on the bottom is what was on the top, 3x minus 2, and it'll have to stay that way. So what should cancel here? All I have that can cancel is this x plus 5 on the top and bottom, and I also have here an x on the top and bottom. So my final answer here should be I have a 5 times x plus 1 on the top and the 3x minus 2 on the bottom. All right, 2 more, and these are 2 of the bigger ones going on. Again, we have division, so flip and multiply. For this first one, I have 4 still on the top. I can factor out an x to leave me x plus 6. When I flip and multiply, that means the x squared now goes up top and the 2 now goes on the bottom. First, I'll look at my variables. Well, I have an x on the bottom and x squared up top. That means I can get rid of one of the x's in each place. I also have here, with the 4 and the 2, I can divide each of those by 2. So when I do that, I should have a 2 up top and now just a 1 on the bottom. So all I'm left with, I have a 2 and an x up top, and all I have left on the bottom is x plus 6. X plus 6 times 1 is just x plus 6. All right, and the coup de grace, the last one here. Let's factor each of these. So I can first pull out an x out of this top guy. I'll be left with x squared plus x minus 6. I can also do the same on this part here, just so we can see it ahead of time. When I pull out an x, I'd be left with x squared plus 3x minus 10. Always check and make sure you can't pull out a GCF first. Okay, so let's rewrite this on the bottom. Well, I can even factor this guy even further. So I have the x already. Factors of 6 that subtract to give you 1 are 3 and 2. I need the bigger sign to be positive with the bigger number, and the only way I can get positive 1 is if that's a negative. On the bottom, factors of 24 that add to 11 are going to be 8 and 3. X in each, and to add to 11, they both have to be positive. Now here, I have to flip and multiply. So let's start with the top, which now becomes the bottom. Factors of 10 that subtract to 3 should be 5 and 2. So there's a 5 and a 2, an X in each, and then it needed to be positive. Positive 5, negative 2 is the only way I get to a positive 3. And then the last one, the bottom, which now becomes the top, factors of 40 that add to 13 are 8 and 5. An X in each, bigger number gets the sign in front, and the only way 8 and 5 get to 13 is if they are both positive, both addition. So now, to see what cancels out, I have an X on the top and the bottom, so they go away. I have an X plus 3 on the top and the bottom, they go away. I have an X plus 8 on top and bottom, so they go away. The X minus 2s on the top and bottom go away. And then the X plus 5s on the top and bottom go away. So everything goes away, so my only answer is just 1. My answer to this one is just a resounding 1. And yes, you will see one just like that tomorrow on your test. Alright, now to move on to proportions. Really simple. All you have to do for all of these is just cross multiply and see what ends up happening. So you have 6 times 7, which is 42, equals 9x. Divide both sides by 9 to get your final answer. X will equal 42 over 9. I can reduce that, divide them both by 3. I can get 14 over 3 for that answer. For number 18, same thing. I have 6 times x will equal 8 times 4, which is 32. Divide both sides by 6, and then reduce if I can. I should get 16 over 3 as my reduced fraction answer. Some will come out evenly, some just will not. In this one, I have 7x equals 6 times 2 is 12. So x will equal 12 over 7 when I divide, and that one can't even be reduced. For number 20, I'll have 2x times 5 is a 10x. 4 times 13 is 52. So x will equal, when I divide by 10, 52 over 10, which is the same as 26 over 5, another fractional possible answer. 21 and 22 get a little bit more tricky just because we have these, x minus 4 instead of just an x or just a 2x. So what I need to do when I cross multiply, I can do 2 times the quantity x minus 4 equals 9 times 10, which is 90. So when I simplify, 2x minus 8 equals 90. I'll add 8 to both sides to get 2x equals 98. Divide both sides by 2, and that gives me an answer of 98 over 2, which reduces to 49 as my answer. In 22, same idea. 4 times the quantity, x plus 3, equals 9 times 9, which is 81. When I distribute, 4x plus 12 equals 81. Subtract 12 from both sides here. You're left with 4x will equal, this gives you a 69. And x will equal then 69 divided by 4, and that cannot be reduced any further. Okay, continuing on. 23, very similar still. So now we end up having x's on both sides of the equation after I cross multiply. I do 3 times x, which is 3x, and then this is 8 times the quantity, x minus 4. I'll distribute that right-hand side to give me 8x minus 32. I then need to now combine my x's. So I'm going to bring this 8x to the other side by subtracting it from both sides. When I do that, I'll be left with a negative 5x equals negative 32. Then when I divide both sides by negative 5, I will get x equals positive 32 over 5. Negative divided by negative, giving you that positive. Okay, in 24, same thing. When I cross multiply, 9 times the quantity x minus 5 equals 4 times the quantity x plus 6. Make sure you keep those quantities together. Distribute them through. 9x minus 45 will equal 4x plus 24. I'll subtract 4x from both sides to get me 9x minus 45 equals 24. I will now add 45 to both sides and get 9x is equal to 69. And then from there, I need to then divide both the top, and the bottom. But what I do, when I subtracted 4x, 9 minus 4 should have been, I should have 5x here. So this should be 5x is equal to 69. So divide both sides by 5, so x equals 69 over 5 as your answer. For number 25, In this one, we have x plus 5 times x minus 2 is equal to 6 times 5, which is 30 when I cross multiply. In these last four, this is the area where you have polynomials and quadratics coming up. I need to FOIL this out. I will get x squared plus 5x minus 2x and minus 10 equals 30. When I simplify this, x squared plus 3x minus 10 equals 30. Anytime you have a quadratic like this, what you need to do is get everything onto the same side of the equal sign. So I'm going to subtract 30 from both sides to get this quantity. X squared minus 3x minus 40 equals 0. And the reason I need that is because I then need to factor. Factors of 40 that subtract to give you 3. Those are 8 and 5. The x in each, bigger number gets the positive. The only way I get to 3 is if I subtract 5 from 8. So each of those, or that factor equals 0. That means I set each one of them equal to 0. So x plus 8 equals 0, x minus 5 equals 0. So my answers are x equals negative 8 and positive 5. And again, order won't matter whether it's negative 8 and 5 or 5 and negative 8. Here in 26, I need to do the same idea. X minus 5 times x minus 1 equals 4 times 8, which is 32. When I FOIL here, I should get x squared minus 5x minus another x. So minus 6x plus 5 equals 32. Subtract 32 from both sides. X squared minus 6x minus 27 equals 0. Factors of 27 that subtract to give you 6. Those will be 9 and 3. So a 3 in one, a 9 in the other. I need the bigger number to be negative, and the only way I can get to 6 is if they are opposite signs. So that means I have x plus 3 equaling 0, x minus 9 equaling 0. So I have answers will be negative 3 and positive 9. 27, same thing going on here. I have x plus 4 times x plus 2 equals whatever 3 times 5 is, which is 15. X squared, I have a plus 4x and a plus 2x, gives me a plus 6x, plus 8 will equal 15. Subtract the 15 from both sides to give you that expression, x squared plus 6x minus 7. The factors of 6 that subtract to 7 are going to be, factors of 7 that subtract to give you 6 will be 7 and 1. The bigger number gets the sign in front. The only way it goes to 6 is if they're opposite signs. So x plus 7 equals 0, x minus 1 equals 0. My answer should be negative 7 and positive 1 when I solve those two equations. And the last one here, x plus 1 times x minus 4 will equal 5 times 10, which is 50. So x squared, I'll have a minus 4x plus 1x, so that's minus 3x. And then negative 4 times positive 1 is negative 4, equaling 50. I need to subtract 50 from both sides, so x squared minus 3x minus 54 will equal 0. And now I factor yet again. Factors of 54 that subtract to give you 3 are going to be 9 and 6. So the bigger number, again, gets the sign in the front. The other number gets whatever sign makes it to be 3. They need to be opposite signs there. So equals 0. That means, again, I set each one equal to 0. So x minus 9 equals 0. And x plus 6 equals 0. My final answer will be x equals 9. And here x equals negative 6. Well, there you have it. Your proportions and rational expressions quiz. And hopefully this will be a good deal and you can take care of business.